In today's lesson, we are talking about absolute values again, but this time we have blanks in our table. So after this lesson, you'll be able to find missing values in tables or extend that table in either direction using what you know about rates of change for absolute value.
For each table represented below, describe the rate of change, identify the type of function represented, circle the vertex if applicable, and make a quick sketch of the function. So looking at this first table for number 1, we are going to do what we always do. We are going to do the change in x and the change in y. When we have blanks, like we do in this section, you really only need to complete the X's and Y's that pair up, that make an ordered pair. So I would start with these. So looking at my table, from 2 to 4 is an increase of 2. From 4 to 6 is also increased by 2. If I skip this one, it's an increase of 4. That makes sense because from 6 to 8 is also 2. So this is a constant change going down with my change in Y. And again, use your number line if you need to. From 7 to 6 is going left, so that's negative. And then when you go from 6 back to 7, it's positive. That's where this change is coming from. From 7 to 9 is an increase of 2, from 9 to 10. So this looks different, but it's because we have a skip. Let's write that as a rate of change. So here we have negative 1 over 2. For this one, we'd have 1 over 2. Here we'd have 2 over 4, and here we'd have 1 over 2. So 2 over 4 does reduce to 1 over 2. We have two different rates of change. We have a positive and a negative 1/2. You could put that 2 over 4 in there, that is equivalent, but it's sufficient just to have this. If you don't like using this plus or minus symbol, you could write this as 1/2 and then include negative 1/2 as two separate fractions. They do represent two separate fractions. And then my unit rate always has to be per 1. It is equivalent to what I have above. These two always represent the same relationship, so they are equivalent. So I'm going to take my 1/2 and divide. You could divide it on the calculator, or maybe you recognize that that is just 0.5 or 0.5. And that would be both the positive and the negative ratio. And because there is a two constant rates of change, it's basically like I have two lines spliced together, that is considered absolute value. So let's look to see if we can find the vertex. So if I look above, I can see right here is where I go from positive and to negative, or negative to positive rather. That's always going to point to the vertex. The other key when I'm looking at the vertex is it doesn't have a buddy. So see how this 7 and 7 match up? And I'm sure we're going to find that there are going to be some other matches in our table too. Now it's time to fill in the blanks, and we know the pattern. We should be increasing or decreasing by 1. So if I'm going down the table, so if I'm going back down this way, this is where my increasing graph is. This is going to be 7 plus 1 are 8. 8 plus 1 is 9. 9 plus 1 is 10. 10 plus 1 is 11. If I'm going up the table, I'm decreasing. So this should be, I'm decreasing as I'm coming down the table. The values are negative here. So I know that this should be negative 1, just like I knew that this should have been positive 1 and this would have been positive 1. So 8 minus 1 is what gives me 7. And you can see that you have that repeated 8 value, which should check out. So because our vertex is not in the middle of our table, they don't all, but I have the 7 matching, I have 8 matching, and right between those buddy points, I have the vertex, which is 4, 6. To do my quick sketch, like it's asked up here, I am going to look at my change in y's. So I see that I'm going negative, negative, positive, positive. That means I'm decreasing at first and then increasing. So I know the basic shape is a V. And if I'm decreasing first, then my line needs to be going down before it goes back up. So that's all I'm asking for the sketch. Let's take a look at the next problems here. I would like you to do the change in X and the change in Y for anything that is partnered up. So partnered up like this. So my change in X's are all increasing, my change in Y's are all decreasing. I do not have a change in direction. I don't go from increasing to decreasing or vice versa. So this cannot be an absolute value. And as you're looking on here, make sure you're using your number line as needed. So when I'm at 2 and I'm going to -2, I'm going to the left. And if I'm at -2 and I need to go over to -18, it's still to the left. That's why I can see that these are all decreasing. Our table is constant, though. In the change in X, it shows that because from 3 to 6 is increasing by 3, from 6 to 9, everything going down our table is still increasing by 3. Let's make sure that our rates of change are constant. So for my rate of change, I really only have 2 because the next 2 here are exactly the same. And then I have the 1 down here of -16 over 12. This can be reduced. Both 16 and 12 are divisible by 4. So if I divide the top and bottom by 4, -16 divided by 4 is -4, and 12 divided by 4 is 3. So you can see that it does match up here. So I really have only one rate of change, and it is constant in my table. This tells me that this is a linear function. And to do my unit rate, it has to be over 1. 3 does not divide into 4 evenly. So I'm going to use my calculator and divide -4 by 3, because remember that fraction bar is equivalent to a divide sign. And so -4 divided by 3 is 1.3 repeating. So I'm just going to put that as -1.3 over 1. Now we need to fill in our table. And the pattern is going to continue to be the same, subtracting 4 all the way down. And then we can do this last one as a check, is that subtracting 4. And so if I'm looking at my number line and I'm at -2 and I need to subtract 4, that's going to take me to -6. And from -6, if I'm subtracting 4, that's going to take me to -10. -10, if I'm subtracting 4, is going to take me to -14. And it's off the number line, but you can extend yours on your paper. If I go 4 more to the left, that's going to be -18. So this does check out. Start by finding your change in X and change in Y. You can do the ones that are just adjacent to each other. That's going to give you 3. That's probably enough to check out. It's okay to also do these ones with skips. Just know that you're going to have to reduce those fractions. You can see the changes that I have here are changes decreasing by 2.5 over 1. And then for my doubles, it's decreasing by 5 over 2, which reduces to 2.5 over 1. That would be the unit rate. And then you see I have increasing by those same values. So this looks constant to me for the negative and for the positive. So we have 2 different rates of change. So this is looking to me like it's going to be absolute value. So we have a plus and a minus of 2.5 over 1, which is the same as our unit rate because it's per 1. And it looks like this is going to be absolute value. And if I look at my table and when I'm going by ones, I am still decreasing here because I still see my negatives. So I'm going to take 0 and subtract 2.5. And let's look at the number line when I'm here. So if I'm subtracting 2.5, I have to go to the left. So that's going to be -2.5. Then I see -5 and -2.5 again. So because I see those repeated values, this seems to be what my vertex is right here. And also that's the change from a negative to a positive. So from decreasing to increasing. Which would be pointing right there. If I can, now I'm adding, so if I add 2.5 to -2.5, so if I'm over here at -2.5 and I add 2.5, I'm going in the opposite direction. I end up back at 0, and 0 plus 2.5 would be over here as well at positive 2.5. So this fills in my table. My quick sketch of this would be seeing that I have negatives right here in my changes and then positives. That means that my graph is going to be going down, then back up again. I realized we didn't do this for number 2. This was totally decreasing, so it would just, you could do it something like this. This isn't an exact. If your line has less of a pitch to it, that's fine. We're just looking for a quick sketch. In our summary, we've been having the definition of rate of change in unit rate. I just wanted to reinforce that these are the equivalent values and they represent the same relationship. So for absolute value, rate of change will have opposites. It'll have a plus and a minus. Every absolute value has a turning point or a vertex, and you can find this by looking where there's the change from negative to positive. So all of these happen where I see negative and then positive, negative then positive, and it could be the reverse. It could be positive and the negative, but that change is what you're looking for. And it's the one without a buddy. And what I mean by buddy is you can see here that these match up, and you can see here that these match up. And so it doesn't have a partner. Now, these right here don't have a partner, but that's just because we haven't extended the graph, and we could extend it that way. And to make your quick sketch, you are going to use your change in Y. So when I see that these are all negative, then I know my graph is going down. When I see that I have some negative, that's going down, and then some positive, that'll be going back up.